Hello everyone. In this session, let us learn about salts, preparation and uses of salts. I am Srinivas, PGD Physical Science from TMRS, Mahabubabad. Coming to the salts, salts are the chemical compounds prepared by the neutralization of acids with bases. The acids on neutralization with base, they are going to give a salt along with water. See here NaOH is a base. This on neutralizing with HCl, it's going to give salt along with H2O, that is water. NaOH, sodium hydroxide, a base, on reacting with HCl, hydrochloric acid, gives NaCl, salt, with water, H2O. Salts are actually electrically neutral. That means they doesn't conduct electricity when in crystalline form, and they will be showing conductivity in aqueous form. In aqueous medium, they undergo dissociation to form ions, and therefore they will be showing the conductivity in aqueous medium. Okay, coming to this point, neutral. Neutral doesn't mean here what we know about neutral is either neither positive nor negative. But here neutral means here it is neither acidic nor basic. The salt which is formed NaCl is neither having the basic nature nor acidic nature. So therefore we say that salts are neutral. And the salt has two parts. The positive part is cation and the negative part is anion. Cationic part comes from base and the anionic part of salt comes from acid. Example, sodium chloride. See, sodium chloride is having two parts, that is Na plus and Cl minus. Due to the electrostatic force of attraction, that is an ionic bond will be formed between these two counter ions. Due to this bond only, they are going to be very stable and strong enough. So this Na plus is from where? NaOH, which is a base, and Cl minus is from where? HCl, which is a acid. So in this way, the cation comes from from base and anion comes from acid. Next, in order to understand the salts, our topic is about salts, how the salts will be prepared and what are the uses. In order to understand the nature of salts, we need to know about this. So let us start with a basic salt, that is sodium chloride, NaCl. Coming to its preparation, this NaCl is mostly available in seawater. We are all familiar about this point. We know that salt is generally separated from seawater. No need to prepare. There is no need to prepare this, but we can prepare this sodium chloride by simple neutralization reaction. Just now we have seen that neutralization of acid with base, that is HCl. Not all acids on neutralization they give sodium chloride. All acids on neutralization with base, they are going to give salt, but that salt will be not always sodium chloride. That may be different. Here, neutralization of hydrochloric acid with a sodium hydroxide, NaOH, will be giving NaCl, that is sodium chloride with water. Next, coming to its uses, to enhance the taste of food, we will be using sodium chloride in our kitchen. We are all very familiar about this. Our mother will be adding salt. Without adding salt, we can't taste our food. And this is also used as a preservative in the pickles. See, most of the pickles, they will be very highly concentrated with more salt. Because of this high concentration, the microorganisms which fall into that pickle will be killed, so that the pickle will not be spoiled and that is going to remain for long time. And the other use of this sodium chloride is it is used as a raw material to prepare other chemical compounds like sodium hydroxide. Just now we have seen NaOH, sodium hydrogen carbonate and sodium carbonate, and many other compounds are there, etc. So in this way, this sodium chloride will be used in the chemical industry as a raw material. We all know the raw material is nothing but a starting material to prepare other materials, other substances. Next, the second salt is bleaching powder. We all know about this bleaching powder. The chemical name of bleaching powder is calcium oxychloride, CaOCl2. Coming to its preparation, chlorine gas on treating with dry slaked lime. Dry slaked lime means here which is free from aqueous medium, which is free from water. CaOH taken twice is slaked lime. That is going to produce calcium oxychloride and water. Cl2 chlorine gas on reacting with dry slaked lime, CaOH taken twice gives rise to CaOCl2 calcium oxychloride, which is the main ingredient in bleaching powder. That means bleaching powder is not only calcium oxychloride, it is also having some other compounds, but mostly and abundantly calcium oxychloride, which is responsible for the bleaching nature and oxidizing nature of this bleaching powder along with water. Right. Next, let us see the uses of bleaching powder. Here, bleaching powder is used as a bleaching agent. Bleaching means which will be used to remove the waste or unwanted waste material in the textile industry, paper industry, and leather industry. By proper bleaching, a cloth will be getting a smooth texture and also high quality. And proper bleaching of the wood wood pulp will be bleached thoroughly to remove the green waste. See, wood pulp means that will be having wood means that will be having many impurities in the form of green waste. So all those will be washed with bleaching powder. And in the leather industry also, this will be used as a bleaching agent to smoothen the skin of animals, which is nothing but leather. Next, this bleaching powder is used as an oxidizing agent in many chemical reactions. In many chemical reactions, this will be used as an oxidizing agent. To oxidize other chemical compounds, we will be using this bleaching powder. And as a disinfectant to treat drinking water, we all know that municipal staff will be adding a particular concentration of bleaching powder to our drinking water that will be killing any germs if at all it has. So in this way, the water will be purified by using this bleaching powder. And also to prepare chloroform, this bleaching powder is also used as a raw material to prepare chloroform, which is anesthetic. The next salt is sodium bicarbonate. This is known as baking soda. And coming to the chemical formula, it is NaHCO3, sodium hydrogen carbonate. Its preparation by treating sodium chloride. We have discussed in the uses of sodium chloride. So sodium chloride is used in making sodium based compounds. So this hydrogen carbonate is one of the chemical compound which is prepared from NaCl. See, this NaCl, sodium chloride, on treating with ammonia NH3 and carbon dioxide CO2 and water H2O, it is going to give us NH4Cl, ammonium chloride, plus NaHCO3, sodium bicarbonate. And here let us see the uses. Coming to the uses of this, it is used in bakery to prepare the food items. We all know that in a bakery we mostly have cakes, bread, biscuits. These are made by using bicarbonate, sodium bicarbonate. This bicarbonate, see here in this chemical reaction I have clearly given sodium bicarbonate NaHCO3 on heating, it is going to give us sodium carbonate along with CO2 gas. See, I have shown an arrow pointing upwards, which means the gas is evolved. CO2 gas is evolved plus water. The CO2 released on heating baking powder makes bread cakes smooth and porous while baking. See, this wheat flour, which is mixed with all the ingredients and also with sodium bicarbonate, whenever it is kept in the oven due to the heat in the oven, bicarbonate is going to release carbon dioxide. This carbon dioxide, whenever it is trying to escape from the floor, it will be leaving some pores, which will be giving the smooth texture, smoothness to the bakery food items and porous nature. Okay, and this sodium bicarbonate is also used as a mild antiseptic. This is used as a mild antiseptic, not a strong antiseptic agent, but this is having some mild antiseptic properties to treat the septic. Whenever we have a cuts in the wounds, cuts due to wounds, we will be this can also be used as one of the ingredient in that, and as an ingredient in antacid. Okay, due to its alkaline nature, this is used to treat antacid. We all know about what is an antacid, right? In the uses in the applications of acids and bases, we have seen that. Next, coming to washing soda, Na2CO3 10H2O. The chemical formula of washing soda is Na2CO3 10H2O. That means decahydrated. 10 water molecules will be surrounding around Na2CO3. Why only 10 water molecules will be surrounding around Na2CO3? We will discuss in the end of the session. Now let us see the preparation. On heating sodium hydrogen carbonate, it liberates carbon dioxide and sodium carbonate with water. Just now in the bicarbonate application we have seen that sodium carbonate on recrystallization, it is going to give washing soda. Recrystallization means that will be treated with water, so that will be acquiring its water of crystallization, then that is known as recrystallization. Here the water of crystallization in the case of Na2CO3 is 10. 10 water molecules will be surrounding one sodium carbonate molecule. Next, coming to the uses, this is used to make glass and to make soap, and also that is used in paper industry, and also it is used to remove the permanent hardness of water. This permanent hardness of water is due to calcium or magnesium sulfates and chlorides. So that calcium and magnesium ions will be replaced by sodium ions, which will be treated. That means the hardness will be treated. Hardness will be gone by heating with sodium carbonate. In the manufacture of sodium based compounds like borax, Na2B4O7 10H2O, this borax will be manufactured by using sodium carbonate. Next, now let us see what is water of crystallization. See, water of crystallization is a fixed number of water molecules present around one formula unit of a salt. That means if there is one formula unit of salt, a particular number of water molecules will be surrounding it. That particular number of water molecules is known as water of crystallization. See, if you take the example copper sulfate pentahydrated, actually copper sulfate is colorless. Without water molecules, it is colorless. On crystallization only, it attains blue color. So that means this water of crystallization is also giving color. It is imparting color to salts. Not in all the cases, but in few cases, few examples. Next, sodium carbonate decahydrated, plaster of Paris, CaSO4 half H2O. Here half H2O means, is it correct in writing half H2O? What is the meaning of that half H2O? Actually, half molecule doesn't exist in the nature. It means that two calcium sulfates will be surrounding will be surrounded by only one water molecule. That means one water molecule will be shared by two calcium sulfate molecules. So each calcium sulfate will be sharing how much water molecule? Only half. So that is the meaning of this. Next, gypsum. See, there is a slight difference between gypsum and plaster of Paris. In gypsum, one calcium sulfate will be surrounded by two water molecules, and in plaster of Paris, only half water molecule will be surrounding the one calcium sulfate. So let us see it in a diagrammatic form. See, this is a molecule of copper sulfate pentahydrated. See, in the middle we have copper sulfate. This copper sulfate is surrounded by how many? 1, 2, 3, 4, 5. 5 water molecules like this. Not more than that. Not more than that or not less than that. This is known as water of crystallization. Thank you for watching.